Okay, everybody. I think we're still having a few people trick in, but in the meantime, let's kick off. I'd like to welcome you all to the Accion Labs Heal demo session. We had a previous webinar a couple of months ago, and now we're transitioning as we enter this year into getting into showing some more of the capabilities. Next slide, please. So with you today is myself, Darrell Brown. I head up cloud and infrastructure solutions, including offshore delivery for Latin America for Accion Labs, and work with our partners and friends at Heal Software. Today we have Girish, who will be walking through a brief introduction. He's Chief of Sales and CMO for the company, and Howard, who will be going through the demonstration component. Howard is our Director of Pre-Sales over at Heal, and the genius of helping our customers get up to speed on the product. Let's talk a little bit about Accion Labs. So Accion Labs, we are a global innovation and engineering company. What does that mean? Is we provide innovative solutions and onshore, nearshore, and offshore development for our customers, from migrations all the way through to new software development, AI, and big data. We have about 3,500 employees around the globe. We cover the USA, Singapore and Asia, India, and Europe. We work with companies like Heal to help both build their software and deploy their software solutions, and large enterprises that are looking for digital transformation solutions. And with that, I will hand over to Girish, who will give us a brief introduction on Heal, and then walk through some of their offerings. Over to you, Girish.
Thank you, Darrell. Good morning, good evening to everyone. Very happy to speak with you today. Heal, we are just thrilled to partner with Accion Labs in bringing the solution to Fortune 500 companies. We are a 13-year-old company that is funded by Avatar, used to be previously funded by Norwest. We have a global presence in pretty much all continents at this point, other than Antarctica. And again, we have incorporated AI/ML tools, artificial intelligence, machine learning tools, in enhancing the IT ops posture for large enterprises and medium enterprises. And we do work with a lot of verticals. We started in the BFSI space, banking, financial services, but since then, over the past number of years, have expanded the offering to every enterprise. If you are a CIO or an IT ops in charge, or an AI ops person, or a SRE in a medium or large enterprise, we understand your pain. I think you have a number of challenges. Number one challenge is, how do you make sure that every application that you have provides a service level to the users, whether they be customers or they be employees or partners or others, at all times, by not throwing a lot of money into it, by optimizing your cost. Tough problem, and a lot of stuff have happened over the years in helping you solve the problem. But digital transformation obviously has made this problem more challenging as well. Some applications are on-prem, some applications are in the cloud, private cloud, public cloud, and some are SaaS. And then there is a continuous movement of applications being migrated over between these domains, especially going from on-prem to private cloud or SaaS. So with that framework, what we are addressing is a part of this problem to help you and make it easy for you. Rishabh, can we move to the next slide? So we have three components. You can look at observability as one part of it. Number two is, we call it AI-assisted analytics. And the third part is automated healing. Observability, every compute, storage, network application has to be monitored. We no longer live in a time where we can let anything work by itself. So there is a way to monitor metrics or KPIs or performance of every virtual or physical device out there. And that can be done using either putting a monitoring tool, agent, etc. And that's one piece. Number two piece is they collect information. They collect information on a constant basis, every minute in general, oftentimes sampling and so on. But end of the day, there's a time series of every metric that comes through. The good part is we can spot issues. The bad part is way too many alerts that come with it. So human beings, even though we are still damn good as a class of things today, human beings, but we can only do so much. Thanks to AI and machine learning, we can use these tools to help us to sift through a large volumes of data and give us the right insights that we need. And that's what the AI assisted analytics helps us with. And then the third part is everything has to be actionable. It's good to know there is a problem, but more importantly, we need to know what can we do about it. Is it really a problem? What is causing the problem? How can we fix it? And what can we do? So that's the part of automated healing. So automation is very important. And as anyone that is a practitioner in the IT ops space knows, it's important to have a level of automation coupled with insights and analytics and intelligence that is real time. So that's what we do. So we can predict problems, number one. We can triage and figure out where the cause is, and then we can fix it. And we've been fortunate to work with leading analyst firms, and they give us a lot of insights and help us position this, also highlight the issues that are faced by large and medium enterprises. Rishabh? This essentially everybody out there on the planet is vulnerable to issues. Even the mighty who have instrumented their IT environment so well, they still end up with outages or anomalies at various points in time, some a little more than the others. And the key thing to note here is oftentimes it's not the very obvious thing that is causing a problem. It's one thing leading to another, and causing an issue. So it's important for, as human beings, we can only look linearly, we can think in one dimension, but machines, on the other hand, can help us correlate between various metrics, correlate between various domains, and provide us the type of insights that we need. And that's why it's AI-assisted human makes it a lot more worthwhile for us over time. So number of things here. One is we can provide early warnings with the type of tooling and the type of analysis that we have using machine learning. We can come up with early warnings at various times and say, hey, if this trend continues, we're going to have an issue, and here is what you can do about it. So that's one. Number two, with too many alerts, give you a simple example, large enterprise that has top application that serves millions of customers, ERP system handles billions of dollars a day in transactions. Just that one application produces 10,000 alerts a week. It's impossible for any IT team to go and chase all of them. And the good news is many of these alerts are similar, are groups. Because of one problem, number of alerts come up. So we need to know what is similar alerts, group them together, so we don't need to address all the key issues. Number two, we need to understand what is causing the problem. So that's causation. I know that causation is a difficult problem, but what we have found is the thesis that in an IT environment, if there's a problem, it is because it is caused by something. It doesn't happen out of the blue. It doesn't happen for no reason. So with that thesis in hand, it's about finding that. It's about finding a needle in a haystack. Thanks to the approaches that we have implemented, we can actually find that as well. And again, we can work agentless manner and ingest data from existing monitoring tools. You never have to repeat anything. And then we can then provide the type of automation that is needed in order to make it happen. So if you're an AI practitioner in an IT ops environment, you got to ask yourself these questions. What are the key issues that I have? Why am I not able to solve with existing stuff? And what do I need to do in order to resolve them? And then fourth part is how can I do this effectively? And if you kind of look into that, we have tried to address that using the solution that we have and the approach that we provide. Rishabh? And again, these are numbers. If you do this right and do this well, you can get a lot of ROI, return on investment. And our customers have found this, and it's important that you measure these things. So alert compression is an example, the reduction in mean time to resolution, and also avoiding issues, very important stuff. And especially mean time between incidents is a key metric. All of this, both from a value point of view as well as a cost point of view, helps every enterprise, and especially when you're going through a digital transformation. Rishabh? Busy slide, but key takeaways. We are user focused. That means it's the user experience and the service level that matters. Number two, the tooling can have lots of versatility. It can be deployed on-prem, cloud, or as SaaS. We announced a SaaS product earlier this year. And then it can be agent or agentless. If you already have agents, we can ingest data from that using connectors. So we work closely with various both commercial as well as open source monitoring tools. And then it's all about integrating deeply with certain applications such as SAP so that you can get more insights. Any application that opens up for us to look into the modular level, we can then get much better insights and much better ability to do this. And finally, it's all about actionable. So you can work with ITSM tools like ServiceNow or PagerDuty, or it can even be tied to any workflow automation tools that are out there. And that's what we want to make it happen. Rishabh, let me turn it over to Howard. Howard, over to you.
Sure. Can everyone hear me now?
We've got you, Howard.
Okay. Rashib, can you stop sharing so I can share my screen? Thank you. All right. 1 second. All right, can everyone see my screen?
Perfect.
All right, for the next few minutes, about actually the next 15 minutes or to 20 minutes or so, I'll be going over a live demo as well as sharing screenshots of some of our features that are new and which are extremely exciting. So let me just go off this live demo first. This is our demo site. So not all the data is here. This demo was made using some of the real customers' data. We scraped the data and then we're able to construct an application environment that is a lot like an actual customer. You can see right away, a lot of the stuff that we do, leveraging AI, ML and stuff, the fundamental portion, obviously, is the ability to construct a detailed service dependency map, such as this one. This covers the entire application stack, so you can say it's end-to-end. And then we also collect the flow of information, meaning, who's doing a request and then who's doing the responses. This way, later on when we do for root cause troubleshooting, and then as well as finding the correlation factors that make up a lot of the values that we do, we do need to construct this kind of map. And I'd like to add that a lot of our customers are gigantic. They're huge. It's tens of thousands or thousands or tens of thousands of instances. And if you cannot provide us, some of our customers cannot provide us this kind of data because it's always changing, and sometimes CMDB cannot be kept up to date. But our ML technology can actually leverage the information, the metrics, and the events that's passed on to it and construct something like this on its own. Now, it's not as accurate, but it is something that we can do as well. Now, today I'd like to demonstrate to you mostly our signals, lead signals feature, which covers the following things. It covers our proactively, the prediction, outage prediction feature, as well as our root cause analysis feature. And the other features I'll be going over on a slide deck. So let's first look at the lead signals, which I'm showing you now. When I drill down to what we call lead signal, right, you'll see right away that this is a feature that aggregates multiple events together. And right away, this is very, very important. The capability to quickly correlate and then stack together related events. Why is this important? Because imagine that you have 5 different monitoring tools, one for application performance, one for infrastructure, one for, let's say, Prometheus monitoring clouds, and then one for network, and then you also use logs. A lot of make extent to use logs to figure out applications or maybe database. But what I mentioned so far, that's already 6 different monitoring solution. Every single monitoring solution, you're monitoring 10 key metrics. Now you're dealing with dozens and dozens of metrics already. And if you put everything together, what's going to happen is that every day you're going to get dozens, if not hundreds of thousands of different events, different alerts that are coming in. When you look at individual events, right, what you want to know is, should I focus on this particular alert, this particular event over another one? Which one should I focus on? Because right now the customers are complaining about, let's just say, search function. Which events, which alerts should I focus on, which will impact the search function? So this is something that our tool actually does. It actually tracks all that stuff from multiple ingestion sources. And as you can see here on the left-hand side, we group them together so that if it's not related to something you care about, it wouldn't appear. And right away, this will help you to organize and to prioritize. Next, once you get a lead signal, tells you that something's went wrong, you want to find out the root cause. So this is where you can drill down, and then you find and through the heat map, you can click on things which are red and pink that tells you something is wrong and something you should be aware of. Now, in this case, you can see logs per minute count. It went beyond and exceeded our dynamic threshold. And this is also where a feature that I want to talk about, because a lot of times when you're dealing with many different tools, operations spend a lot of time trying to set the perfect threshold. You do not want a threshold which, well, if you set it too low, you'll get hundreds of alerts every minute, all the time, every day. But you don't want to set the threshold to be too high neither, so that you'll miss some of the critical, warning signs. So for us, our dynamic threshold capability, our algorithm does not only average, take into account of last, couple of days of data and average that at a particular time. We add a lot more logic which treat seasonality and then take into other things into account as well. So here you can see that this particular metric has exceeded and it's, first of all, it's very important. We know that it impacts the application in an important way. And then moreover, we know that at this particular time, there's an issue. So we provide root cause analysis in forensics. This is where, if you look at it, there's a problem, the DB lock. We tell you the process which has been locked. What do you do next? There's a heal button here. Now, the heal button is an actionable that is tied to a script. If you have a playbook for an automation tool, that's fantastic. You can make it so that, the category DB lock for this particular name, it will automatically heal. So if you click on the button, it'll generate the script. We have a framework for this. If you have multiple scripts that you can execute and you would like to find out which script has the best results via a feedback loop, we can do that as well. So we have a solution recommendation feature that over time, we can tell you which script that you execute for this particular problem has the best results. Okay. Now that's not something I'm going to show in the demo, but that is a key feature that we do. That is brand new, and I know that a lot of in terms of aiding decision making, that is something that a lot of people want, a lot of companies want. Going back to this screen, this is very, very, very important. Now, if you look at the time, 22:44, I have an lead signal told me that something's happening that I should care about, and I showed you when I clicked on the when I clicked on root cause, it tells me about a DB lock, right? If you do not take care of the problem bubbles up to app server. Why? Because earlier on, right, when I showed you the map, the service dependency map, you can clearly see that the application tier, well, it makes requests to DB tier and expects a quick response. If DB tier, due to locks or due to other issues, it could not respond, then later, at a later time, app server will have problem. And you know what? The web server depends on the app server. And now we have, now at 21:16, right? A search function went out of commission. It just multiple times the average response time. Now, the reason why I want to talk about this, and this is why the timeline is so important, at 22:44, right? Right when you first received the lead signal, this is before the problem has occurred. You just received the early warning, all right? Had you acted, clicked on the heal button with a playbook, with a script tied in the back, you would have prevented what's happening at 21:14 on the web server, and you would have proactively prevented what happens at the web tier. In a nutshell, this is how we can do proactive and preventative healing. Now, there's no guarantee that, in this case, obviously, this is our demo system. It's a very good use case where we're able to alert, 20, 30 minutes ahead. In real life, it really depends. And I certainly cannot, we cannot guarantee that happens every time 20, 30 minutes. However, 60 to 70% of the time, you will get a couple minutes of notice, 3 minutes, 2 minutes ahead of notice, notice ahead of the outage and knowledge about to happen. So you do have time to navigate. And then you can see through our root cause walk capabilities, you're able to either quickly solve the issue, or if you have playbooks ready, you can resolve the issue. And if you have playbooks with multiple scripts, we have solution recommendation to help you make that choice, to make the best choice. All right, so this is the end of my web demo. Rashid, can you go back to the presentation so I can talk about some of the features that's not part of the web demo, but that is already in our product. Let me stop sharing. Hold on. All right. All right, next slide, please. All right, thank you. So I want to talk a little bit about under the hood, right? The state-of-the-art AI ML, because ultimately our product, the RCA you saw, the predictive capabilities, and then a slew of capabilities is really based on ML rather than the typical, rule-based systems that I think a lot of the older generation, the tools rely on for automation and then for, for root cause analysis. And our ML, we have multiple patents, and some of the key ML features I would like to show you in the next couple of screenshots. Next slide, please. First, I want to talk a little bit about anomaly parallelization. So, but even before the anomaly parallelization happens, we first would take multiple ingested sources and we'll run data normalization on them, because cleaning up the data is probably one of the most important things to leveraging any type of ML model. And this is where one of the challenges occurs, is when, it's basically to get the clean data, because no one ever gets clean data. You're always missing gaps here and there. But once we clean up the data using our algorithms, then first thing we do is we do anomaly parallelization. Again, why is this important? Because when you have an alert flood, the first thing you want to know is which alerts, which events are the most important, which ones should I focus on? If you have 10 and you only have time to work on one, which is that one or two things that I know if I address them correctly, properly, that perhaps other problems which happen only because they're dependent on the original issue, these will be resolved as well. So that's our anomaly parallelization feature. And you can see the anomaly score that we apply to each one that will give us the indication. So we calculate these scores. Next, please. Okay, this is a little bit hard to see, but what I want to talk about in this slide is that we want to give a little bit more insight on ML learning. And this is something that's very close to what I just talked about in terms of prioritized anomalies. Okay, so if you have lots and lots of issues, right? Lots of events. We want to rank these events based on our machine learning algorithms so we can get the accurate root cause analysis. So if you look at right away on the right-hand side, right? We list top 10, but obviously the higher the correlation score for each event, the more likely that is a root cause. And the more data that we have, the more accurate this becomes. In essence, what we're trying to do here is that we're trying to mimic the human experience, right? Because when we troubleshoot, when humans troubleshoot, what we do is using our experience, we're trying to correlate, oh, this happened is because of this, because of this, because of this. We do that in our heads. And this is why experienced people are very good. They perhaps don't need AI ML to do this. They can look at a problem and figure out right away. But for a lot of other people, as we scale our organization, right, you can't find everybody who is extremely knowledgeable. And extremely knowledgeable people, they're usually very busy solving problems. So what we're trying to do with event ranking system is to mimic the human experience in troubleshooting by providing using machine learning based technology for accurate root cause analysis. And again, here we assign scores to each event based on correlation as well as the previous score, the anomaly score. We combine that together to make the event ranking. Next, please. All right. So on this slide, I want to demonstrate our capability to help our customer to identify some of the most important metrics. On the left-hand side, you have the workload metrics. These are metrics that matters to customers that are related typically to outages, right? So you're talking about failures, you're talking about slow response times, you're talking about unavailable services. These are green, and then the blue ones, they're the ones that we pick for each host, some of the most important metrics that have highly correlated property based on 1 month of data. Why is this important? Imagine, again, I said that, you know what you want. Most of our customers have a very good idea what outages are. What they do not have that great idea, or maybe some of them do, but they're always asking validation for typically what they call, a lot of people call go-to metrics. Metrics that matters, metrics that cause the green color from a host perspective. Does CPU matter all the time? We don't know. How about memory? These are often some of the most important ones, but do they really matter? How much do they matter? What is the correlation score for each of these metrics towards the workload metrics, towards the metrics that cause outages? We calculate this stuff for you, and we tell you what you should focus on out of the sea of metrics. Next, please. Now, this slide and the next one, we leverage this. We leverage our ML-based, the modeling to model between hardware metrics and then also the outage metrics or application high impact application performance metrics. We map them together because we have a correlation score. We can use that then to determine capacity forecasting as well. We can do capacity planning based on that. The difference between this and a lot of the competitors, I know that most major cloud, they offer free capacity planning tools. The major difference is that we model using AIML rather than linear projection, and also we're not only take into account hardware based. We're not trying to sell more cloud instances. We're trying to figure out what is the optimum outcome of hardware. And then based on our modeling, if you raise up the transactions. Next, please. And capacity choke analysis is we use the same algorithm to look into the previous data, in historical data, what are the capacity bottlenecks? You can see here, you can see whether it's memory or CPU, looking at the past data. And that way, if you expand the choke, if you'll address application problems. All right, next, please. All right, this is the last slide last feature that I want to talk about, and it's ML-based bad job monitoring. I know this is a bit niche, but some of our customers recently has been requesting this. So this is something that we have added in as well to be able to intelligently troubleshoot and then rank, the bad jobs. All right, so this is the end of my my technical demo. Going back to you.
Thank you very much, Howard. So that was very, very interesting. And one of the things I want to add here is working with Heal, it enables us to deliver solutions to our customers as well that allow them to have more predictable outcomes when it comes to ensuring their systems are operating at full potential, especially in the digital transformation world, with a number of our high-tech customers and financial customers. So with that, do we have any other questions for the Heal team or Girish or Howard or myself?
Encourage you folks to ask any questions that we can answer, or you can also get in touch with us after this webinar, and we'll be happy to talk to you and give you, having a one-on-one conversation. But I do want to add a couple of things to what Daryl mentioned. Number one, the partnership with Accion Labs gives us the overall capability end-to-end, going to an enterprise, figuring out if it's bringing the right value, implementing it, integrating it, and deploying it, and also providing any additional services associated with that. Number one. And then number two, the time it takes to get something deployed has come down drastically today. Because of the multiple deployment approaches that we have, on-prem, cloud, and SaaS, and also given a lot of the auto discovery tools, it makes it very quick in terms of trying it out and then seeing if it adds value. So there is one question here from Jay. Can you tell us about the process you have for training the ML algorithms to reduce false positives? I can take that question. Jay, great question. So the way we train the model is a number of things. Number one, if you have logs or any historical data, we can use that to get a head start. So that is one. And many companies, again, based on the data policies and the storage they have, they store anywhere from last 1 week to multiple months. In fact, I was talking to a customer yesterday. They have 8 months of data that they have stored, which is kind of unusual. Most customers don't do that, but if you have that, we can use it to get a head start. Number two, we can also ingest real-time data and train the models. And then number three, we use something called transfer learning, and by which what it means is in the same type of enterprise or same type of vertical, what we have learned from other customers. It's, let's say you have 100 metrics. In reality, the 100 metrics aren't necessary at all in order to make the type of insights that we're doing. Maybe about 5 to 10. The question is which 5 to 10 to use. And that we can learn from transfer learning from other verticals and say, hey, let's use the memory of this or the CPU of that, or something else, right? And that should, in general, get us on a quick start instead of, so the approach is start from a few metrics and KPIs and grow as needed, as opposed to starting with the boiling the ocean and then coming down. And then to reduce false positives, specifically here, in terms of, if you look at the alerts, one thing we do is we look at alert similarities. So, and the way we do that is by looking at the cause. So we do a causal graph, and then that will determine what causes what when a problem happens. And we use that template in order to look at all the alerts and then group them together. So that becomes more robust way of grouping it, which means there is less chance of false positives there, number one. Number two, we also can look at alert similarities. So when an incident happened or when an anomaly happened, by the way, a challenging thing for AI ops and APM and monitoring and all of this stuff is that the number of incidents are not as much, especially in enterprises that are that run pretty well. The number of incidents that happen, aren't that much. Let's say you collect data every minute. You have a lot of data that comes in, but incidents happen, maybe once a week or twice a week, whatever sort. So it is very hard to use supervised learning. It's very hard to do any of that kind of approach. So we implement self-supervised learning, which means we use part of the data itself to predict the other part. So you're teaching the model itself to predict, right? So that also helps a lot in this case. And then when an incident does happen, if there is feedback that you can go back and say that, hey, at this time a particular incident happened, then the system, the model can actually at that point train itself to say that, hey, when the incident happened, these were the scenarios, these were the different sequence of things. And then that gets more and more robust as we have more and more data that we pump into it. So a number of approaches, there's a lot of art and quite a bit of science. It's all about taking both and then reducing the false positives.
Thank you, Girish.
I think Jay had a follow-up question as well. After an event occurs which Heal missed, how can we make Heal learn to not miss that again? So because the incidents are far and few, typically when an incident does happen, and by the way, it's all ongoing. The initial part is just to start, right? And the whole idea is that this continues, ad infinitum. So number one thing for us is every time we get a signal, an incident happens, is really a signal, right? In this case, and if we can use that information, then the model will actually rally behind what all led to that event, right? Sequence of things that led to it. What got affected? What metrics got elevated or went out of the range, the normal operating range in this case. So all that stuff becomes really useful over time. So every time something happened, and if there is a repetitive pattern, the idea for us is to separate between seasonality, which occurs all the time, right? Every enterprise has seasonality, whether it's daily, hourly, weekly, monthly, quarterly, it may be. We need to tease out seasonality at all times. It's important. Number two thing is we need to take out any known type of events. The idea for machine learning is to know, if this happens, if something else, gets contributed downstream. Like when Howard showed the bad jobs, especially in bad jobs, this becomes an important issue. When something issue happens with a bad job, you can see downstream a number of other things that happen. So the more we are able to see when an event happens, it can go back and learn that part, and that gets more and more robust. And if there's repetition, that is the best thing that machine learning can do, right? Every time an anomaly happened, these things were a result of that, which means now we can go back and fix that once and for all. That can never repeat. So that becomes two. Third is totally random stuff that happens, which is hard to predict. That is something that we got to learn from it, underlying causes we can extract out, under any other underlying correlations that we can extract out. And then that helps us sort of figure out some more insights into it. But of course, then if that particular cause happens again, then we can be a little bit cautious and say, hey, last time when this happened, there was a problem. Could that be true? And either the system can percolate that up to the administrator, who can then go and explore this and look into it in more detail. So that's how we look at it, Jay. By the way, the future is bright. I think the timing is never perfect. It's never been better for implementing these tools. I think many years ago, pieces were missing. It was hard to figure out what the value is. I think today, more and more enterprises are seeing value out of implementing AI ops and associated technologies. It's easier to measure, it's easier to plan, and it's also easier to deploy and implement and manage as well. So the time has never been better in terms of doing something like this. And also the problems faced by CIOs and IT ops leaders and SRE leaders is running between on-prem and cloud and SaaS is a tough battle. And I think anyone who's been there understands it. On one side, there is convenience. On the other side, there is cost. And then the third side is visibility. Combining all three and optimizing for all three is essential, because sometimes when you put everything into the cloud, your visibility comes down. Cloud, it's very convenient, obviously, but the cost also can get unwieldy oftentimes. So managing those three aspects and getting the right visibility, getting the right level of granularity of visibility, and making sure that end of the day, eventually, there is no degradation in service level or performance for the customers is key. So it's a juggler we see on Fisherman's Wharf, right? And they do a great job juggling. I think it's possible with enough training. That's what they do, and then with a little talent and with a little passion. So that's what this in this particular approach as well.
Any other questions? Thank you, Girish. That was really great. So I think we're coming up on our time. I'd like to say thank you to everybody else. If you have any further questions, drop an email to us. I think, Girish, you can drop your email address in the chat there, or Howard can, and or
yeah, I'll put it up.
Or back to this one. So really do appreciate it. So I'll drop mine in there so you can. So again, thank you very much, and Girish, great being partners with you.
Likewise, Daryl, great partnership with Accion, and we hope together we can bring right solution for our customers.